Welcome to this new tutorial about FicsIt-Networks, a computer mod for Satisfactory. Today we're going to talk about how you can use tables in Lua. A table could be viewed as an infinite table with two columns with a key and a value. In the first column you have the keys and in the second column you have the values, and there can only be the same key once in the list, okay? So that means you have each row has a unique key or a unique value in the first column. In the second column you can easily repeat multiple different kinds of values, okay? So with this you have then essentially creating a list of key value pairs. A table can be stored just as any other value in a variable. So we're gonna store now, we try to create a new table in the variable myTable. With this you can now use the table literal, which is done with those two curly brackets, to create a new table value and store it in the myTable variable. When you now want to create or just simply access a key value pair, you can use the corner bracket operator to now access a key. So in those two brackets you can now just simply provide a single parameter, which is essentially one single expression that evaluates down to a value, to any kind of value. That essentially then tells you like that's the key you want to try to get. So this can be anything from a number to a string. Now let's try out a string, okay? We take test, for example. Okay, so now we say, okay, we want to access now a row in the table test, okay? And we want to assign a new value, so just as normal assigning so like this whole expression could be viewed as evaluating down to a variable, and now we're gonna assign a new value to it, just like we did up here. And we can, for example, store a value meep in that. Okay, when we now want to, when we create this here, the table doesn't actually contain a row with the key test string in there yet. But when we try to access it here, this is the case. It now creates a row in the table with the key test and with the value meep. And what we can now do is we can just simply try to print those. So we're gonna try to use the same thing. So this here evaluates down to a variable, or finally, because it's just a parameter, to the value of that variable. So this evaluates down to a variable, and we're gonna try to access the value of that variable, pass it to the print, and the print will now print meep, as you can see right here. Now, what if we don't do this? So with those two dashes, we just create a single line comment. So this line gets ignored now, and we're gonna say, okay, like we're gonna try to access the test row now. So like the key test, but we don't have any. We don't have set anything there yet. If we try to run that, you can see nil, because like this here just simply says, okay, we try to access it, but this is nothing, and nothing, as we have already learned, is nil in Lua. You can also override stuff, so we try to do this here now. If I could write, we're gonna try to assign a value, a number, for example, and we're gonna try to print that now. You can see we got the number instead, so it got overridden. So what if we want to get rid of a value? So like, what if we want to remove an entry, a key value pair? This is simply done by assigning nil to it. So this now looks like, okay, yeah, okay, now we got a row with test with the assigned value of nil, but internally, like this is actually true, but internally it actually gets also completely removed out of the data structure, out of the table itself. So you don't have in there now a row with key test and a value nil. With the table literal, you can also directly initialize the table with some default values. if you, for example, want to have a string, if you want to now, for example, add a key value pair with a string key, you just write the name of it directly into that. So you cannot use spaces for the key in this case when using a literal, but you can use any other kind of stuff, like if you would use a variable name, for example. So like you have the same rules as for variable names. So you can, for example, now say test and then assign it to the value of that new key value pair. So for example, meep. So this line here in within those two curly brackets just means, okay, we want to add now a new key value pair to our table. The key is the string test and the value is the string meep. If we're gonna try to run that now, you can see, okay, it prints again meep, just as before. If we want to now add more, you have to add a comma and then write the next key value pair in there. So we could try okay with If we're gonna try to run that now, you can see, okay, it still stays the same because we still access the test from up there. And you can also do now okay, and now we're gonna see Strings are also a bit special in terms of accessing them, because since if you follow the naming scheme here, just like you have to do with variables, you can actually, instead of using the cornered brackets here, you can use just simply that period operator and then say period dot and then the name of the and then like the string value of the key you want to access. So if you're gonna run that now, you can see we still get because it now tries to say, okay, in that table, try to access now a string key, and that string key has to have the value okay. In this case, we can change this to test, and you can see it now returns meep. And I mean, you can still use any other kind of value, so you can use numbers also. That's also the case. You can still do that. You can also use even functions if you want to. You can also just use integers, and you can even use booleans if you want to. That's like what you put in there in the values doesn't matter at all. And with this, you can use it to access like very easily without the cornered brackets string attributes. So like if you try to do that now, so instead of like directly in the literal, you can still do something like meep and then assign like false there, and we can try to still use it that way, and then you have it false there. So that this period operator is essentially just simply a syntactical sugar, so that you don't have to write those cornered brackets and those quotes there, those double quotes. And I mean, you can also use the period operator to actually create a value in a table. So you can easily do like something like this here, and then say, okay, we're gonna print now meep, and you can still just simply use then in this case, and it will then create the value in there. As said, it is just as simple as syntactical sugar as if you would do those cornered brackets and those double quotes. And you can use this especially together with functions. This goes even to a step further. So for example, for now you have like you can see we create now a string key in that table func and assign it to a function, and we're gonna try to access this now with that period operator there. So this can be viewed just as a normal variable. So like if you just write my table or whatever, or any other variable name, this would be essentially the same. So you can do everything like you can do with a variable. So we can even now call this underlying function with those normal brackets, with those brackets. And you can see we got those values. We can even bump that further up, because the problem is this function here is not aware of the table itself. So you could try to like then do my table but imagine like this changes later on. We pass through some variables. So like, okay, we're gonna say, okay, we access my table here, and then we say, okay, my table has now a kind of initialization value. So like text, and this is now our hey ho. Okay, and we're gonna say, okay, we're gonna try to access this now, return it. So we're gonna do this here, my table dot text, because like, okay, so we are a function, and this function just simply wants to return the text and 42. And when we're gonna try to do that now, okay, this will work just fine. But what if? Okay, what if we're gonna we pass it now to different the table to different variable? So this is now, let's call it test. We're gonna pass my table in there, and we use the my table variable for something else, or essentially make it that it doesn't exist anymore. This is especially important with function scopes. I mean, we will talk about functions in a later tutorial more in detail, but like for now, my table is now nothing. It doesn't have a value, and we're gonna try to do that now. You can see attempts to do some garbage. It does not work, because when we now say, okay, we're gonna try to my table. Hold on. So I'm gonna do now test, because now in test the function is in there. We're gonna try that. You can see it still tries to do something that doesn't work. This is simply because of following thing. Test func, that works. It calls the function. It goes in there, and what happens in here is now it tries to check. It tries to get now the value of the my table variable. But before we actually have called the function, we set it to nil. So that's why attempt to index a nil value global my table, because my table is now set to be nil, and we cannot access it anymore, and we don't have any clue about that within that function. But we can still kinda work around this problem by just simply saying, okay, we're gonna take the table we want to call that thing on. So let's call it meep. Why not? We're gonna call it meep, and we say, okay, this needs to be passed as the first parameter to it, and then we say, okay, yep, so this is essentially test now, and then we're gonna call it. Yes, sure. So we got now meep text in our function, which returns the text 42. Test is now the same as my table as before, and my table itself gets set to null. We're gonna call now the test function with the first parameter test, and as you can see, it works again. But this seems to be a little bit weird, because now we have like test.func.test. Why can I do that like implicitly? And the catch is it can. So the only thing we have to do is just get rid of this parameter here and use a colon instead of the period. So this colon essentially only works in association with actually calling a function, and it will then just simply take the table from there, from the left side, the table. We're gonna try to access now the key func and call it. Takes that value and passes it as the first parameter in there, and then it still works. So if we now pass like a second parameter, we can access it over there. So we can pass it through that way. And because of this system, usually what you do, if you say, okay, this function should be viewed as a member function, so it has to care about which table it actually is part of, you usually call these kinds of variables then self, because that just simply relates, okay, I mean myself, the table that actually calls it. So in this case, now the table that is stored in test. and this is just normal naming convention you should try to follow. And with the column you have this separation. So this is why in a later tutorial you will see we use columns instead of periods at some different points. Like you can see in this table, we still use text to get the value of hey ho. So if we, like when we print test, we're gonna have to use the period to access this value, and this is just a plain value, and that's why we have to use the period to be able to get that value. We cannot use a colon there because the colon only works for function calls, for member function calls. So you can see, yeah, it misses some stuff. This doesn't work. So, but in a function call, if we do it that way, in our func, it will miss the self variable because we have not passed it through there. So it does. So the function call itself, like when the function gets called, is not aware of the test table we actually want to call it. So imagine the test variable contains a reference to a component. We call the function now. The function doesn't have any clue about which component you want to talk to. So that's why you have now to either pass test as first parameter there, or you use a colon instead, which should be usually done. When using APIs and stuff, like you will be later be introduced to the component API, when you use a function there, like the proxy function, which takes strings, you don't want to use the colon, because the proxy function can work. It doesn't matter which table it is. It doesn't care about that. So that's why you don't have, why you don't use the colon there. Use the period, because the proxy function doesn't care about the table of which it got called from. You can even go that far and store it in any kind of other variable you want to. We can just copy the, say, okay, we now have the meep variable and that holds the proxy function directly. Now we can use meep instead of just calling meep instead of calling component.proxy, because the proxy function doesn't care about the table it comes from. But for members, for member functions, which is the case when you try to reference a special kind of table you create, or like a reference to a component or a component in the computer network, or a machine in the world or something, you care about the table it calls from, and that's why you have to use the colon there. Tables are also used to represent arrays. Arrays are just simple lists. So far we have learned tables can be used as key value pair maps essentially. So like a table which with a key and value pair are also called maps, because it maps one key to a value. And we can also use it as an array, and an array is just simply an ordered list. So you can say, okay, at the first entry there is this value, at the second entry there is this value, at the third entry there is this value, and we have an overall of 10 different values. And the essential part of this is just the key, the value type of the key in the table has to be an integer, and that's it. And if you now create a continuous row of key entries with with numbers constantly increasing by 1 integers, you then create a table. If you have a break in there, like you say you have an entry for 1, entry for 2, entry for 3, and an entry for 5, the entry with 5 is not part of the array, because there has to be an entry with the key 4. So how does this look like? So you can for this you don't have any special period. You can use that with 1 and stuff. Now what you have to do instead is always use the corner brackets there, and then just provide the numbers. Arrays in Lua begin with 1. So to address the first entry in an array, we use the 1 instead. So we assign this to a new value, for example test, and now we can do the same thing. We're gonna go in there and then we say okay, we want to have the second entry, assign it to a new value, okay. We're gonna take the a third entry, and the third entry should be meep, for example, and then we can just simply print those out if we want to by addressing those just as we have, or as we already know. For example, the second entry with 2, and we're gonna print that and we're gonna okay. Great. You can also just usually override them as we already know, or you use the string you can use the table literal instead. So how does this work now? So you cannot assign it that way. What you should do is just simply provide the value directly. So if we're gonna do this here now, meep, comma, and then we're gonna say test, and okay, we have in the first entry of our table meep, and the second entry of our table test, or in our array test, and in the third entry of our array okay. So if we're gonna have a look at that, gonna see test for the second entry. For the first entry we got meep, and for the third entry we should have gotten okay. Great. So if you want to get now the length of an array, so this doesn't work for maps or broken arrays essentially. It essentially just counts if there is so is there an entry 1? Yes, okay, we have an array length of 1. Is there an array entry of 2? Okay, yes, we got an array length of 2. Okay, is there an array entry for 3? Yes, okay, the array length is 3. Is there an entry for 4? No. Okay, so the whole array entry is 3, and it doesn't check, okay, is there an entry for 5? It ignores that. It goes from 1 to whatever last value you have there, and that's then the length of the array. To get the length of an array, you can use just simply plain a hashtag. So if we're gonna try to do that now, you can see we got an array length of 3. Great. So now let me show you what happens if you have like a break in there. So we already know, okay, in the third entry we have our okay. We skip the fourth entry and we go directly to the fifth entry. And we're gonna store there now, for example. Okay, and we're gonna try to get the array length now. And you can see it's still 3 because we have a break in there with the entry of 4. So if we want to have the entry of 5 in there now, you can go in there and just say table 4, and then assign it to fix the gap or something, and you can see we now have an array length of 5. If you want to add a value on top to a new array, this is rather easy to manage. You can just simply go in there and then say, okay, give me the length of the current table, increase it by 1, and at this entry we're gonna add now a new value, and we're gonna try to do that now. You can see we now got 6 entries because we now have at the 6th entry the add value. A problem emerges now when we're gonna try to remove stuff out of an array. We cannot just simply assign it with nil because it detects it as an array. What we have to do is instead is use the table library that is already provided by Lua internally. So we can use this by taking the table library. So we just write table, and then we now access the table library, and now we call a function. This function doesn't care about the table library itself, so we use a period instead, and we're gonna call the remove function. The remove function takes at first the table we want to remove an entry from, and then we just simply provide the index of the entry we want to remove. For example, we want to remove OK, so that after this operation, we have now in the first entry meep, second test, third fix, at the fourth ha, and at the sixth, and the fifth, then add. Okay, so we that everything shifts one step down and the OK gets removed. So we just provide the index 3. Because that's also called the index, like which entry this is. This is then the index, and so the third value, or at index 3, we want to remove that entry, and we do that with the remove. And if we're gonna print that now, we can see, okay, we got a 5. So we can also, if we now say, okay, we're gonna print like now the third entry. Previously it was okay, but what is it now? As you can see, it's fixed, because that was previously the fourth value. The third value got removed, so the fourth value got shifted down to the third value, and we have there a fixed entry. There are more functions in the table library, like an insert function that allows the same thing as we have done with our add there. But if you want to learn more, please have a look at the Allure documentation to learn more about these kinds of functions. So if you can see, we have now added a new entry at the 6th place, and if we have a look at that, we're gonna see, okay, we got now sub in there. So this was a brief introduction onto tables of Lua, which are very important, especially for managing larger code bases when you write Lua code, for example, or just essentially later on interacting with all the different components of FicsIt-Networks. I hope you enjoyed the video, it helped you out, and I was Praxi from CodeD from MusicbyAden, and say bye bye until next time, and as always, keep coding!